Hello, everybody. So, in this section, we're going to talk about different sampling methods and how they are used in statistical analysis and other real life problems. So, before we get into that, let's go over some basic definition. So, statistics is a study of procedure for collecting, describing, and drawing conclusion from information. A population is an entire collection of individual that we want to get some information from, and a sample is basically just a subset of a population. So here is a little um, image that might help you remember the definition. So a population is pretty big. So let's say this is everybody in the United States. So everyone in the US, right? And let's say you want to know um, the average height of people living in the United States. So it's kind of impossible to get everybody's heights because there's just so many people. So what people do is they take a sample of it, which they just take random people, measure their height, and then do some statistical analysis on that. So that's so this is a sample, which is like a small subset of the population, and that's what usually people do. And ideally, we want our sample to represent the population as closely as possible. Unfortunately, there is no direct way of doing that, but there are methods that comes really close. So let's do some examples. So suppose an owner of a large restaurant chain wants to do a study about all 500 employees. He choose 50 employees to include in the study. So the goal of this is we want to identify what is our population and what is our sample. So it's kind of easy to see from our example that the 50 employees from the 500 is our sample. So our sample here is the 50 employee selected. And our population is all 500 employees. Okay, so how do we pick our sample? Well, the best method all involves some kind of random selection. So actually, let me do that in black. The best method all involve random selection. And the most common, and in many cases is actually the best is something called the simple random sampling. Is simple random sampling. There are others that we're going to talk about, but this is probably one of the best. Okay, so a simple random sampling. So a simple random sample of size n is a sample chosen by a method in which each collection of n population item is equally likely to make up the sample. So the idea here, and this is the key thing, is that every individual has an equally likely chance of getting chosen in your sample. So let's say you want to play the lottery. So this is a quick example. So let's say you want to play a lottery, and let's say you pick 6 numbers, 1 to 42, but there's no repeats. So let's say you chose the numbers 6, 13, 5, 9, 8, and 36. So this is you chose these 6 numbers. And the lottery officials, they randomly choose 6 numbers. Oops. 1, 2, 3, 4, 5, 6. So they randomly choose 6 numbers, 1 to 42. And if your 6 number kind of matches their 6 numbers, then you win $1 million. So that's basically the idea here. So the question is the number 40 as likely to be selected in the winning group of 6 numbers as the number 4? So the question is are the lottery official, if they pick a number, is the number 4 as equally likely to be chosen as the number 40? And the answer is yes. Yes. So each ticket has the same chances of being selected, right? Because remember, the idea here is they randomly choose 6 numbers. So each number has the same chances of getting chosen. Could all the 6 winning number be even? So let's say they randomly choose 6 number, and it so happens that all of them, 2, 6, 10, 20, 30, 24, all of them are even. Can that ever happen? And again, the answer is yes. It is possible. And remember, the idea here is that in a simple random sample, every number have an equally chances of getting selected. Okay, let's say your friend chose the number 1, 2, 3, 4, 5, and 6. Could she ever win? Can it be possible that the lottery official pick the 6th number and they happen to be the number 1, 2, 3, 4, 5, and 6? And the answer is yes. It is possible, but is kind of unlikely. But again, the idea here is with simple random sampling is that every number has an equally likely chance of getting selected. Okay, so the next type of sampling is called sample of convenience. So sometimes it's impossible to do like a random selection. So people will actually use a sample of convenience, which is not drawn by a well-defined random method. There is some caution about this. This is very biased, and we could people usually use this if there's no other method that could be chosen. So for example, let's say you're a construction engineer. So this is you. You're an engineer, and you want to test blocks of bricks. So these are bricks. There's 1,000 bricks or blocks. They're very heavy. And you want to kind of test each one of these blocks. You want to test 10 of them to see if they're like very efficient, that none of them are defected. So if we do a simple random sample, then we could possibly choose a brick that's way in the bottom, and then he would have to lift all these other bricks off to get the last brick here. So it's very time consuming, it's very difficult, it's not very productive. So what people would do is they just select the first 5 or 10, the first 10 blocks on top, and just test those and see if they're defected or not. And that could work because we're assuming that all the blocks are not that different from one another. Okay, so there's a couple problems with this sampling. So So problems with sample of convenience. Okay, so there's a couple of problems here. One is that the big problem is that they may differ systematically in some way from the population. And remember, the whole goal about sampling is that we want our sample to represent the population as closely as possible. With sample convenience, that could be really hard. So some caution is that we should not use this except when there is no other option. Okay, so the next sampling is called stratified sampling. So our idea here is that we have some layers. So we have a population and we actually group them into categories and we call them stratas. So once you have all these stratums, we do a simple random sample and we do an extra layer, and then these individuals will be in our sample. So we have 3 layers here. So a quick example will be, let's say you have people in your math class. So this would be people in your math class, and you want to group them up into, let's say, their ages. So 1, 2, 3. So let's say this will be people who are less than 20 years old. Let's say these are people between 20 and 25, and let's say this will be people who are more than 25 years old. Right? And then you do another layer. And then you want to do a simple random sample from your stratums here. So randomly you choose, say 2 people from each category. And then these will be your samples that you're going to work with. So we have 3 layers kind of going on here. Okay, so the next one will be clustering sampling. And clustering sampling is actually very similar to stratified sampling. And a lot of people actually confuse from these two. It's a very common mistake, but there are 2 very different sampling. So in clustering sampling, the idea here is that from the population, we do put them into groups or clusters, but we do a simple random sample and choose which clusters we want to do our statistical analysis. So which one of them is our sample. So let's do it like a quick example here. So let's say you want to do a survey in a neighborhood, and you decide to group the people up into their streets. So these are all the people in First Avenue. This is all the people in Second Avenue, and then this is all the people in Third Avenue. So very similar to what we did here, where we kind of group them up into category. But the difference here is that we're gonna do a simple random sample. So we're gonna randomly choose a cluster. Let's say we choose the 3rd one, and then that will be our sample. So there's no 3rd layer. We just, whoever is in that clusters, we do that, they will be in our sample. Okay, so let's do a little, so clustering versus stratified. So yes, they both divide our population into groups, but with stratified, we do a simple random sample. I'm just going to call it SRS for now, is chosen from each group. And with clustering, a random sample of group is chosen, and every member of that chosen group is in the sample. So next we have systematic sampling, and this is probably the easiest to remember out of all the other sampling, is that you want to order your individual in some sort of way, and you pick every case individual to be in your sample. So for example, let's say there's a group of people in line in a Starbucks, and you want to take a survey and ask them about how they like their coffee or something like that. So what you do is that since they're already in line, you pick the third person to survey, and those people will be in your sample. So something that we should note is that usually this kind of sampling is done in assembling lines. So if a company makes cookies and they have like an assembly line, so they test every, let's say, 20th cookie to see if they're defected or not defected, and in their sample, let's say like they're not, then it assumes that all of the cookies are okay. So that's typically how this type of sampling is used. Another one is called voluntary response sampling. This is actually the least popular one. Not a lot of people actually use this type of sampling, so I won't go over a lot, so don't really worry about this one. Lastly, we want to talk about what's the difference between a statistic and a parameter. So a statistic is a number that describes a sample, and a parameter is a number that describes a population. So some examples is, let's do this example. So we want to know from the following if this is a statistic or a parameter. So let's say A. 57% of the teachers at Central High Schools are female. So for this one, the number 57 is a parameter because it describes the entire population of teachers in the school. Okay, let's look at B. In a sample of 100 surgery patients who were given a new pain reliever, 78% of them reported significant pain relief. So the idea here is that, or the key word here is a sample. So that kind of tells you that the number 78 is a statistic. Because it describes a sample.